All right. Let's move my side for now. The question was, we had two circles, and I've got to note the center of that circle. Very important. Okay. Hold on. Draw another circle. So, and the error said that we couldn't tell that the two circles were congruent because we didn't know the radius of the circle. I couldn't tell whether or not circle C and circle D were congruent. Well, if we're going to call them circle C and circle D, that means that the center of the circle on the left is C and the center of the circle on the right is D. But it means that this segment, CD, is the radius of circle C and a radius of circle D, isn't it? So since CD is a radius of both circles, and obviously by reflexive property, CD is congruent to CD, okay, that means they must have the same radius. That means they must be congruent. That's what they were looking for. Number 18. It says an angle C, measure of arc EF is 100, FG is 120, EFG is 220. Put H on it so that GH is 150. Explain why H must be on EF. When we start drawing pictures like this, it can get a little bit tricky. So here we have some circle. Okay. And I'll start with some point here. We have EF is 100 degrees. So if this is E, F could go either way around the circle, but we'll say it goes about here, so we'll put it about there. So EF is 100, okay? It says FG is 120. Now, FG could be going around this way and be a 120 degree angle, okay? Or FG could be coming around this way and being a 120 degree angle. Okay? I'm not sure. I'm not sure which way G went because we aren't told which way it's going. Either way, it's 120. But we are then told, the next thing, that arc EFG is 220. So EFG, if we go around this way, if this is 120, then EFG is 220. If we put G this way, then EFG would actually be 340. So this must be my G. Okay, G can't be there. So G must be there, and that's 120. If H is on circle C so that GH is 150, explain why H must be on EF. Well, GH is 150, so it doesn't say which way it's 150. It might be 150 this way, or it might be 150 this way. If it's 150 this way, that's 120 plus 30 more, so that's one possible location for H. This is 220, so if I add 150 down this way, that becomes 370, so that's 10 degrees over. So the other possible location for H is right there. But either way, both possible locations for H have to be on arc EF. It's the only way it works. Because you got 150 this way or 150 this way. Either direction I go for G, it winds up back on EF. They're not in the same spot, but they're still in the same arc. But that's a different concept. I mean, it takes a lot of what if type thinking when we're working with circles and putting points on circles, just knowing our lines. All right. let's look at today's stuff. It's really quite simple. Inscribed angles. Yesterday we had central angles, which meant the vertex was at the center of the circle. Today we have an inscribed angle, which means the vertex is on the circle. All right? So the vertex is at a point on the circle. When that happens, we have an intercepted arc. Every inscribed angle intercepts a specific arc. So it's like what is being cut out by that angle. And very simply put, the measure of the angle is 1/2 the measure of the arc. Now, yesterday we had a central angle. I said the measure of the angle equals the measure of the arc. When we have an inscribed angle, we're dragging out and narrowing that angle, aren't we? The arc itself is not changing. It's like we're dragging it down here. So the angle is narrowing. How much does it narrow to? 1/2. So if this angle has measure, say, 90 degrees, then this arc is 90 degrees, which means this angle would have to be what? 45. And quite honestly, it's usually pretty obvious which way double half. Some people do mix it up and say, oh, if this arc is 90, then this angle is 180. Really? Stop and think for a second. Does that look like a 180-degree angle to you? Not really. Well, maybe to some of you. In a very bent and twisted way. But no. All right? So what if I put the vertex? Now, this is interesting. What if I move my vertex to this angle, say, up here? But I still intercepted the same arc. Now what's the measure of this angle? Still 45, isn't it? What if I move the vertex like way over here? Still 45. And so, in fact, so long as it doesn't go into the intercepted arc here, if I go into the intercepted arc here, now it's not 45 anymore, is it? What would it be?
180.
Minus 45. 135. Why? Think about this for a second. And if you think about it, it makes total sense. If this arc is 90, how long is this arc of the circle? 270, right? So if I put my point vertex here and intercept, now I have the opposite arc of my circle intercepted, don't I? What's half of 270? 135. They're like little puzzles. We just got to figure them out. Okay? But key concept here today, and this is the big one, central angle, same as the arc. Inscribed angle, half the arc.
What do you call that thing about it?
Still inscribed because the vertex is on the circle. And it's still half the arc, just it's a different arc. Okay? We already answered this because it's fairly obvious. If two inscribed angles intercept the same arc, those angles must be congruent. Now, gosh, what do you think we're going to do with something like this in the homework? We'll say, oh, this angle is 3x plus 10, and this angle is 2x plus 20. Find the value of x. You're going to set them equal. Yeah, we've done this before. Oops, minus 10, sorry. I get x equals 10. So that means each angle is how much? 10. No.
Just kidding.
40. Each angle is 40 degrees, which means this arc would have to be 80, twice as much as the arc. 2 times 10 is 20, plus 20 is 40. 3 times 10 is 30, plus 10 is 40. See? And I actually had an example of the measure arc is 80 degrees. See? 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 Sometimes rather be lucky than good. All right. Inscribed also applies to polygons. Now, this is going to be an interesting little thing. If I take this polygon and I inscribe it in a circle, so all four vertices are on the circle. If I pick any pair of opposite angles, so I'll call this one angle 1 and this one angle 2. The arc intercepted by angle 1 is this much, isn't it? That's the arc intercepted by angle 1, if I just take angle 1. If I take angle 2 and look at the arc that intercepts, that one begins here and goes here. Now, the arcs are not congruent, so the angles are not congruent, right? But the arcs add up to the whole circle, don't they? So that means the angles must add up to how many degrees? No, because inscribed angles are half the arc. So if the sum of the arcs is 360, the sum of the angles has to be 180. So that tells me, and the same would hold true for angle 3 and angle 4, we just get different arcs again, that if I have an inscribed quadrilateral, the opposite angles must be supplementary. If my quadrilateral is inscribed, I may not know much about them, but I know that these two angles have to add up to 180. They aren't necessarily going to be unless the arcs are congruent, but they have the opposite angles in an inscribed quadrilateral add up to 180 because the arcs they intercept add up to 360, and the angles are half the arcs. So we can do some neat stuff, and actually that's what this was, that page was. So let's take a look at this. Let's find the value of x. If s is 90, what's the value of x? 90. And y would be 100. Okay. Let's find the measure of arc, R-U-T. Well, that would be R to U to T. That would be the arc. Where is the angle inscribed? Catching it? Right back there. So the measure of the angle is 90. What's the measure of the arc going to be? Did you really just think that that arc is only 45 degrees? It has. How about URS? So URS is my arc. So my angle is angle Y. Angle Y, I said, is 100, so the arc would have to be 200. Okay? You see how we use these things? I mean, we do have to remember that double half relationship. But for the most part, it's fairly straightforward. Let's solve for x and y here. Now, we're given some information, but not all of it, but that should be okay. 2x, here's my angle. And a lot of times it helps to redraw and highlight. There's the arc it intercepts. What's the arc total that's being intercepted? 130. That means this so 2x. Well, what's the angle have to be then? Half of 130, which would be 65. So x is 65 halves, isn't it? Okay. So what do? We actually found the measure of the angle and then solve for x. How about for 5y? 5y, if I look at that angle, that gives me this arc. Well, I've got 80. Ooh, I don't know how much is left there, so maybe I should figure that out. 60 and 70 is 130 plus 80 is 210. So how many degrees are left for this arc on the outside? 150. So the blue highlighted arc here is 150 and 80, which is 230. So this arc would have to be, angle would have to be half of 230, which is 115. So y equals 23. Because 115 divided by 5 is 23. But what you're seeing are really good examples of problems where we don't go directly to the answer. We've been talking about this for a long time. These are the ones that give people fits because you got to kind of reason through it before and solve a bunch of other things before you can get the answer. They're like those little fetch quests in games. Okay? Well, here's what we really want you to do, but before you do that, you have to do A, B, C, and D. And once you've done those few things, then you can go actually get what you need to get. Okay? Same idea here. Sometimes you can go directly to the answer. Sometimes, like here, we had to figure some other stuff out first, then set up the equation so I could solve. So don't be afraid of having to do that sometimes if the answer isn't obvious and direct. This is kind of a fun one. It's not too bad. I will tell you this point is the center of the circle. Okay? This point's the center of the circle. So if that's the case, what's the measure of this arc? It has to be the same because it's 96. If that's 96, let's measure this angle right here. 48. Half of 96, yes. Now, honestly, one of the things when we do this quiz, that happens every year, is that people get so hung up on the half, the arc, they forget that the central angle is the same. So you are going to have to kind of keep in mind what rule to use depending on where the vertex of the angle is. And we're going to be slowly building a chart here. All right? If the vertex, B-E-R, I can't spell, T-E-X, thank you. Hate my life. Okay, so if the vertex is at the center of the circle, then the angle is called a central angle. And the measure of the angle equals the measure of the arc. Okay? If the vertex is on the circle, it's called an inscribed angle. And the measure of the angle is 1/2 the measure of the arc. That's part of what we're going to do. What we're going to learn later on is what happens when it is outside the circle and when it is inside but not center. Okay? That's what we still have to learn. So we're going to wind up with 4 different formulas based on where the vertex of the circle is. And that's going to be our key component. Where is that vertex? See what I can fix that now by highlighting the key component. That's no more. That's lovely, by the way, with the hairband around your nose. I think it's a new fashion statement. Everyone's going to be doing it. Okay, so this isn't something we're going to worry about at all today, but it might be a good idea to maybe start copying this chart down into your notes just because we're going to fill it out later, and so you start getting the idea of how that's going to work. Yes? Inscribed means scribed basically exactly onto. In order for a polygon to be inscribed, the vertices have to be on the circle. So that's just our definition. Inside is going to be interior, outside is going to be exterior. It's going to be really, really complicated like that. So anyway, that's kind of the beginning of the chart. We will finish that chart out next week and use that. But this is the whole focus of everything we're doing in this portion of Unit I in the third benchmark is looking at these angle relationships within the circle. Okay? Your assignments, for those who may have missed it. What time are we out of here? Oh, 2, yeah, you got like 10 minutes. Got lots of time.
Is that a thing? Okay, yeah, that's on my spot.
667, 3 through 25. So remember, we're jumping ahead. Hold on. That's wrong. That is wrong.
There was a game that I used to play. Chase down things.
Whew, I'm glad I looked. Glad I looked. No, it's 676.
Never changed that.
Wow.
6A.
Yeah, not 667, 676. Minor typo.
Minor? You completely changed what you do.
So 676.